Hi, all. Good evening. Today we will discuss about some of the topics of Z transforms of some common sequences. So first we will discuss about the unit sample sequence, unit impulse sequence, otherwise called. So we are given with x of n equal to delta of n. So that is the unit impulse sequence, and we know that delta n is equal to 1 when n equal to 0 and delta of n equal to 0 when n not equal to 0. And also we have the z transform x of z equal to z of x of n, which is equal to summation z of delta of n, which is equal to summation n equal to 0 to infinity delta of n z power minus n. So this is the z transform formula. And now for n equal to 0 alone, we'll have the value to be delta of 0, which is going to be 1, and for the other values it's going to be 0. So here you can see very well. So this is what happens. Therefore it's a transform of delta of n, which is going to be 1. So the region of convergence is the entire z plane. Delta of n, if you take the z transform, will be 1 for all z. Now coming to the next sequence, we call it as the unit step sequence, x of n equal to u of n. We know that u of n will take the value 1 for n greater than equal to 0, and for 0 when n less than 0. And now we have this transform x of z equal to z of x of n, which is equal to z of u of n. And what is that? Summation n runs from 0 to infinity, u of n is z power minus n, which is the rule. And you know very well, for n greater than equal to 0, the value of u of n is 1. Therefore we'll get 1 into z power minus n. And now we can just substitute the values of n to be 0, 1, 2, 3, etc. And you can run over. So it will be 1 plus z inverse plus z power minus 2 plus etc. And that will be nothing but 1 plus z inverse plus z inverse whole square plus etc. So which is looking like 1 plus x square plus etc. and which you have the rule 1 by 1 minus x, or 1 minus x power minus 1. And now you can just write this in terms of z. So that is nothing but 1 over 1 minus z inverse, or z by z into 1 minus z inverse, which will give us z by z minus z into z inverse, which is going to be z by z minus 1. So I hope you understand the steps. So the region of convergence for this sequence, the above series converges when modulus of z inverse is less than 1, or 1 by mod z less than 1, or we could see mod 1 by mod z less than 1, or mod z greater than mod 1. So this is the region of convergence, or the series converges. Therefore the region of convergence, or ROC, is the exterior of the unit circle, because when you take mod z greater than 1, so outer part of this circle will be the region of convergence in the z plane. Therefore we can see u of n is a transform when you take is going to be 1 by 1 minus z inverse, which is z by z1 minus 1 otherwise. Therefore the ROC is mod z greater than 1. Alright. Now coming to the next sequence, we have a sequence called unit ramp sequence, where r of n equal to n into u of n, and r of n will hold good for n if n greater than equal to 0, and 0 for n less than 0. And we have the z transform x of z equal to z of x of n, which is equal to z of r of n, and which will be the summation of n runs over 0 to infinity, r of n is z power minus n, and again summation runs from 0 to infinity. For that n greater than equal to 0, we'll have n into z power minus n. And when you substitute the values of n from 0 till infinity, so you'll get 0 plus 1 into z power minus 1 plus 2 into z power minus 2 plus 3 into z power minus 3 plus etc. Pulling out 1 z inverse outside, you'll get 1 plus 2 z inverse plus 3 z power minus 2 plus etc. And that will give you 1 plus 2x plus 3x square plus 4x cube plus etc. The formula is 1 minus x power minus 2, or 1 over 1 minus x square. So that will be 1 minus z power minus 1 whole power minus 2. So this is the rule we have. Or we can also have z inverse over 1 minus z inverse whole power 2, which is equal to z square into z inverse by z square into 1 minus z power minus 1 whole square. And now the numerator becomes z, and the denominator, when you expand 1 minus z inverse whole square, it becomes 1 minus 2 z inverse plus z power minus 2. And when you take z square inside, you will get z by z square minus 2z plus 1. So that you could write it as z by z minus 1 whole square. The above series converges if mod z inverse is less than 1, that is the ROC is mod z greater than 1, which is the exterior of the unit circle in the z plane. And n into u of n, the z transform will take the value z inverse by 1 minus z inverse whole square, or z by z minus 1 whole square, and the ROC will be mod z greater than 1. Yes, mod z greater than 1, right. Now let us go with the next concept, the exponential sequence x of n equal to e power minus j omega n into u of n. And you have x of n equal to e power minus j omega n into u of n, which will take exponential of to the power minus j omega n for n greater equal to 0, and for 0 for n it's going to be 0, n less than 0 is going to be 0 here, right. So we'll get into the next concept, the exponential sequence x of n equal to e power minus j omega n into u of n. And here you will get this function to be called for n greater equal to 0. We have exponential to the power minus j omega n, and for all the negative values we will be having 0, right. Now let us get into the problem. We'll just take this transform of e power minus j omega n into u of n, which is summation n runs from 0 to infinity e power minus j omega n to u of n into z power minus n. And now since you know very well u of n is going to be 1 for n is starting from 0 to infinity, so we'll have summation n equal to 0 to infinity e power minus j omega n into z power minus 1, which could be written as summation n equal to 0 to infinity e power minus j omega into j omega whole power n into z power minus 1 whole power n. And now this summation will have z inverse into e power minus j omega whole to the power n. And now you will get the expansion to be 1 plus z inverse e power minus j omega plus z inverse e power minus j omega whole square plus z inverse e power minus j omega whole cube plus etc., which is going to be 1 minus z inverse into e power minus j omega whole power minus 1. This is by using the rule 1 plus x square plus x cube equal to 1 minus x power minus 1. And now we can bring this to the denominator, which is 1 over 1 minus z inverse into e power minus j omega, which could also be written as z by z minus e power minus j omega. And the above series converges if mod z inverse is less than 1, or the ROC will be having mod z is greater than 1. That means again the region of convergence is going to take all the place which is going to be the exterior of the circle, of unit circle here. Of course we have the points will be plotted just outside of the unit circle, right. And we know this exponential to the power minus j omega n into of n is a transformably 1 minus 1 over 1 minus z inverse d power minus j omega, which is z by z minus e power minus j omega, and the region of convergence is mod z greater than 1. All right. Similarly, if you talk about e power plus j omega n t of n, that will be having this transform 1 over 1 minus z inverse into e power j omega, or z by z minus e power j omega, and the ROC is mod z greater than 1. The sinusoidal sequence x of n, which is sin omega n into u of n, we are going to see is a transform for this function. So let us first understand what is x of n, which is nothing but your sin omega n into u of n, which could be written as sin omega n for n greater than or equal to 0, and for n less than 0 it's going to be 0. Then we are going to take is it transform x of z equal to is it of sine omega n into u of n, and that will give you summation n equal to 0 to infinity sine omega n into z power minus n. And again you will have sine omega n, you can just expand it as e power j omega n minus e power minus j omega n by 2g into z power minus n. And again when you just try to simplify this, you can just take e power j omega whole power n minus e power minus j omega whole power n by 2g into z power minus n. And now you can just pull 1 by 2g outside of the summation, so we're getting summation equal to 0 to infinity is it inverse e power j omega whole power n when you take z power minus n as z inverse whole power n outside and bring it inside, so it is multiplied and the nth power is taken together, so we'll have again z inverse into e power minus j omega whole power n, right? And now I will have 1 by 2g summation equal to 0 to infinity is it inverse e power j omega whole power n minus you can take summation to the second term, which is summation equal to 0 to infinity z inverse e power minus g whole power n. And now the above series converges for mod z inverse is less than 1, that is mod z is greater than 1. Therefore x of z equal to 1 by 2g. The first term we can write it as 1 over 1 minus z inverse d power j omega, minus the second term we can write as 1 minus z inverse 1 minus z inverse d power minus j omega. And how does it come? We have the formulae summation equal to 0 to infinity alpha power n is equal to 1 by 1 minus alpha, where alpha here is the z inverse into e power j omega or z inverse e power minus j omega, as mentioned in two terms here. And when you cross multiply this z into z minus e power minus j omega minus z into z minus e power j omega divided by z minus e power j omega and z minus e power minus j omega, which will give you z square minus z into e power minus j omega minus z into e power j omega plus z e power e to the j omega into e to the minus j omega. And now you can just simplify this 1 over 2g into z square minus z into e to the minus j omega minus z square plus z into e to the j omega divided by z square minus z into e to the minus j omega plus e to the j omega. I am writing it as e to the j omega plus e to the minus j omega in an order. And the last term positive and negative powers gets cancelled, leaving out 1. And now this is our expression, which could be simplified z square and negative z square is going to be cancelling out and giving only 1 over 2g, and taking z common from the numerator part, we have z to e power j omega minus z e power minus j omega divided by z square minus z into e to the j omega plus e to the minus j omega plus 1. And now you'll get 1 over 2g into z into 2g sine omega divided by z square minus z into 2 cos omega plus 1, and 2g gets cancelled, and you have in the numerator z sine omega by z square minus 2z cos omega plus 1, and you have sine omega into u of n, z transform will be z inverse sine omega by 1 minus 2 z inverse cos omega plus 1, or z into sine omega by z square minus 2 z cos omega plus 1, where the region of convergence is mod z greater than 1 or the exterior of the unit circle otherwise. Alright, now let us get into the last sequence. We have the cosinusoidal sequence where we have x of n equal to cos omega n into u of n. And now you have cos omega into u of n. The function is cos omega n if n greater than or equal to 0. For n less than 0, it's going to be 0. So z of cos omega n into u of n is z of cos omega n is e to the j omega n plus e to the minus j omega n divided by 2 into u of n. Now you're going to take this transform for this function, so you take 1 by 2 outside, and you have z into e to the j omega n plus into u of n plus z you have e to the minus j omega n into u of n, and 1 by 2, that is 1 off, is taken outside for both the terms. And now when you run over this part like the first term, you have summation n equal to 0 to infinity e to the j omega n, and u of n becomes 1 and z into z power minus n is the formulae, and the same way we can express the second term with the negative exponential. So we have 1 over 2 z or z minus e to the g omega plus z or z minus e to the minus g omega. Just cross multiply, you get z into z minus e to the minus g omega plus z into z minus e power g omega by z square minus z e power minus g omega minus z e power g omega plus e to the j omega e to the minus g omega. Now you have 1 over 2 into z square minus z into e to the minus g omega plus z square minus z into e to g omega by z square minus z into e to g omega plus e to the minus g omega plus 1. Of course, you have 1 over 2 by this one square plus z square is 2 z square minus pull out z you have is e to g omega plus e to the minus g omega by z square minus pull out z you have e to g omega plus e to the minus g omega plus 1. Now just trying to substitute the values of the exponential in terms of cosine and sine. You will get 2z square minus z into 2 cos omega by z square minus z into cos 2 cos omega plus 1. And of course you can take 2 1 half into 2 z is common, so you have z minus cos omega over z square minus 2z cos omega plus 1, cancelling 1 half and 2, so you have z into z minus cos omega by z square plus 2z cos omega plus 1, where the region of convergence here is the exterior of the unit circle more is it greater than 1, and that is how your cosine function cos of omega into u of n taking the z transform z into z minus cos omega by z square plus 2 z cos omega plus 1, or 1 minus z inverse into cos omega by 1 minus 2 z inverse into cos omega plus z power minus 2. So in both the way you can express where the region of convergence is modest greater.